All right, so today we're going to look at inscribed angles. I'm going to skip down to the notes, and it says, starting here, at the right, the vertex, the vertex of angle C on circle O is on circle O, and the sides of angle C are chords of the circle. Angle C is an inscribed angle. Arc AB is the intercepted arc of angle C. So that's a lot of information there. We have this word chords, which we talked about yesterday, and we're going to talk about again today. The inscribed angles are just made up of chords. So that's not even really that important to this. It's just the words in there, so let's mention it. What's important for an inscribed angle is that the vertex, where it comes to a point, is on the circle. So that vertex touches the circle. The other important part to notice is that those chords stretch out and come and touch the circle over on the other side. And in between those 2 points is this arc. So this angle, angle C, and this arc, arc AB, are going to have a relationship that we're going to talk about. So we talked about, at the beginning of this unit, the relationship between a central angle. So remember, a central angle has a vertex in the center, a central angle and its arc. So if my central angle is 30 degrees, my arc is 30 degrees. They're the same. Inscribed angles and their arcs are not the same. So our formula for an inscribed angle says the measure of an inscribed angle is half the measure of its intercepted arc. So angle B, so if we're using this example, angle B is half the measure of the arc. So if the arc was 100 degrees, the angle would be 50 degrees. So we take whatever the arc is and we divide it by 2. Or if we were given the angle and we were told that the angle is 50 degrees and we needed to find the arc, we would double it. We would multiply it by 2 to get the measure of the arc. So we won't always have angle B and arc AC. So we're going to use this circle general formula. Angle equals half the arc. And then here we just have a reminder that a chord is a segment in a circle whose endpoints touch the edge of the circle. So like if we go back up to this picture, BA is a chord because both endpoints are on the circle. BC is a chord because both endpoints are on the circle. All right, before we get into examples where we have to calculate, it's important to be able to identify the inscribed angle and the arc that goes with it. So if I look here, identify the inscribed angle. Well, the angle, remember, comes to a point. All angles, like when we drew angles, they looked like this. The angle comes to a vertex, the point. That's what we're looking for. So here's my angle. My angle is angle C. The arc that goes with it is just what is part of that angle. So see when we kind of highlight it all, how they all go together? So my arc that goes with it is arc AB. So if we look at number 2, my angle is angle Q. If I highlight those chords to see where the arc is between, now those 2 purple lines, arc RS. So the angle is angle Q, the intercepted arc, the arc that goes with it, is arc RS. I can work that backwards too. I can say, oh, I see that I have this arc MN. Arc MN, what is the angle that goes with it? Well, if I follow those chords down, I end up at angle P. So the intercepted arc, the arc that goes with the angle, is arc MN, and the angle is angle P. So now we're actually going to skip all of this page. It gets into some corollaries that go with that formula that aren't as important. So we're just going to look at 4 problems here. So if I use the formula for this first one, because I have an intercepted arc, I know it's an intercepted arc because its angle is on the circle. So if I use the formula, angle equals 1/2 arc. My angle is an A. So angle is A, 1/2 stays 1/2, and my arc is 1/16. So this 1/2 arc is really multiplication. So I'm doing 1/2 of 1/16 or 1/16. So I'm doing, here, I'll show you on here. I'm doing 1/16 divided by 2 to get 58. So A equals 58 degrees because A was the angle. So that's my answer for that one. Half of 1/16 or 1/16 divided by 2. So in this next one, again, I know I have an inscribed angle because my angle is on the circle. So I'm going to use angle equals 1/2 arc. My angle this time is right here. That box tells me it's 90 degrees. So 90 equals 1/2. My arc is labeled as A. So 1/2 of A. This one's different. I'm not going to take half of A because I'm not going to get anything. I want to solve for A. The opposite of multiplying by 1/2 is multiplying by 2. So we're dividing by 2. Multiplying 1/2 is the same as dividing by 2. So the opposite of that is multiplying by 2 over 1 or just by 2 on both sides. Because then this 2 cancels with this 2. This one cancels with this one. And we're just left with A over here. So I'm multiplying by 2 on both sides. And 2 times 90 is 180 degrees. So that arc is 180 degrees. Sometimes it can get a little bit trickier. We'll try to keep it as simple as possible on the problems that you're doing on your own. We can see we have B and A that we're solving for in this one. We do have an inscribed angle because that vertex is on the circle. So I'm going to find A first is what's going to be easiest because I know that if I take this part of a circle, this part of a circle, and this part of a circle, it makes up the whole circle. And an entire circle is 360 degrees. So if I do 82 plus 60 plus A equals 360, I can solve for A that way. I'm not even using my inscribed angle formula. I just know that all parts of a circle equal 360 degrees. So I'm going to do 82 plus 60 equals 142 plus A equals 360. Then subtract 142 on both sides. So 360 minus 142. A equals 218 degrees. So we found A. So if A is 218 degrees, it goes, so this arc A goes with this angle. Let me do that in a different color so you can see that. This arc A, 218 degrees, if I follow down those chords, it goes with angle B. So now I'm going to use angle equals 1/2 arc. So my angle is B. I have 1/2 times the arc, which I know now is 218. So I'm going to take 218, which I have 218, that's arc, and divide by 2. And B is going to be 109 degrees. And the last one. We have A, B, and C. So what I know about this arc here is that it's a semicircle because of that diameter. So I don't have to use my new formula. I can just take 95 plus A equals 180. Subtract 95 from both sides, because remember a semicircle equals 180. So 180 minus 95, A equals 85 degrees. So A is done. Then, if I look at B, that angle goes with this arc 95 degrees. So if I use angle equals 1/2 arc, because that's an inscribed angle, because angle B is on the circle, my angle is B. 1/2 times the arc is 95. So then if I do 95 divided by 2, B is 47.5 degrees. So to find C, since we're not on the smartboard and I can't erase, I'm actually going to draw this picture again. There's my diameter. There's B, there's C. So what I know about C is its chords come this way, and this is a semicircle. And we know a semicircle is 180 degrees. So if I use angle equals 1/2 arc, because C is an inscribed angle, C is the angle, equals 1/2 times the arc, which is 180 degrees, because this is a semicircle. And I take 180 divided by 2, C equals 90 degrees. So I actually have not taken a look at this. So let's see. Just like in class, looking at the homework now to decide what I want you to do. I am going to have you do 1, 2, 3. This is the one where we work opposite. Oops, there you go. 1, 2, and 3. This is the one where we work opposite and we divide or multiply by 2 on both sides because we're finding the arc instead of the angle. Same here for still looking. Let's do number 10. And number 10, this, remember, so you want to find angle A. What is angle A? But first you need to remember that this is a semicircle, and a semicircle equals 180. So what is CB? You need CB before you can find angle A. And let's stop there. Let's do 1, 2, 3, 4, and 10. And I'll format this a little bit differently in Classroom on a sheet of paper, so it's not all of the problems for you to see.